Alright, my dear children of class 11 science, we now move to the next problem, problem number 3, and this is actually a problem based on one of the topic you learn in this chapter, flow of liquid, that is principle of continuity. Okay, so let's try to solve the problem. Now problem number 3 says that water is flowing through a cylindrical pipe. So what type of pipe? The water through which the water is flowing? Cylindrical pipe, and that's cylindrical pipe has a cross-sectional area that is 0.09 pi meter square, and in that cross-section area, by what speed the water is flowing? 1 meter per second. Okay, the question says that if the diameter of the pipe is halved, then find the speed of flow of water through it. So in that pipe, if the diameter is made to half, then by what speed the water will flow? The same water will flow. That we need to calculate. So in order to solve this problem, we have the cross-section area, and that cross-section area I write down say as A1, that is 0.09 pi meter square. Okay. Now when this is a cross-section area, what is the speed in which the water is flowing? 1 meter per second, and that speed I write down as B1, which is 1 meter per second. So the speed in which the water is flowing is 1 meter per second. Now the question says that if the diameter of the pipe is halved, if a pipe which has cylindrical shape whose diameter is made to half, then the radius is also reduced to half. So when the radius changes, the area of cross section also changes, and you know when the area of cross section changes, then the speed also changes, and that speed we need to calculate. Okay, so in this question we don't know what is the radius of the cylindrical pipe. So for that I'll just follow this way, since A1 means 0.09 pi meter square. This is the area which is given, but this cross-section area of the cylinder is given by pi r1 squares. So area of cylinder is basically, the cross-section area of cylinder is basically the area of circle, and that is given by pi. The radius I consider is r1 square. So pi r1 square equals to 0.09 pi meter square. So this pi and pi cancel out. Okay, so now we can calculate r1. So to calculate r1, so on the other hand I give square root, and the square root of 0.09 meter square will be nothing but 0.03. So when you take the square root of 0.09 is 0.03, and the unit is meter. That means from this relation we come to know that what is the radius of the cylindrical pipe? That is 0.03 meter. So this is the, it is the initial radius. Let me just write on this way also. It is the initial radius of what pipe? That cylindrical pipe. Cylindrical what pipe? But as for the statement says that the diameter reduced to half, means the area of cross section also reduced to half. So I write out since the diameter, okay, and since the diameter of the pipe, since the diameter of the pipe is halved, when the diameter of pipe is halved, then the radius of pipe is also reduced to half. Then I write down the radius of pipe is also reduced to half. Reduced to half, which means this is the initial radius. So when it is reduced to half means we get the new radius, and new radius will be equals to r2 equals to r1 by 2, just half of this. So it means 0.03 by 2, and the unit is meter. So under this we have a new radius, that is 0.03 by 2 meter. So I'll keep it like this again. Now with this radius I calculate the new area of cross section. New area of what? Cross section. New area of cross section of a pipe. And the formula is A2. I write on A2, and is given by pi r2 square, because area cross section of cylindrical pipe is always given by pi r square. But the new, with the new radius, the area is new area, that is A2 pi r square 2. I pi r2 square. Okay, so let me substitute the value. Pi into r2 means 0.03 by 2 with whole square. So let me open the bracket. 0.03 square means 0.09 pi in the numerator, and 2 square means 4. I write on 4, and this is meter square. So this is the new area of cross section. So under this new area cross section we have to find the speed. So I write that speed as B2. So B2 be the speed, okay, the new speed, the speed of flow of water, the speed of water means the new speed of water through this area cross section is B2. But how to calculate the speed? So in this case we follow the principle of continuity. So write down from the what? Principle of continuity. So as per the principle of continuity, you know the relation A1 B1 equals to A2 B2. Yes, we have learned already. So from here we can calculate B2. So I'll make B2 as the subject. So B2 equals to A1 B1 by A2. Yes, we can write this way also. Now A1 is 0.09 pi into B1 means how much? What is the value of B1? 1 divided by A2 means how much? A2 means 0.09 pi by 5 by 4, sorry, but this 4 will be reciprocal in the numerator. Okay, so I've just done directly. This 4 will go in the numerator because it will be reciprocal. So pi cancel out, 0.09 and 0.09 cancel out. So 1 into 4 is 4. So finally B2 equals to 4 meter per second. So look at the speed in which the water flows in that area, that is 4 meter per second. So this is the solution of problem number 3. So by using principle of continuity we can calculate the speed in which the water or liquid flows through any cross section area through the pipe or through the cylindrical pipe. Okay, so this is problem number 3. Now we go to the next problem now, problem number 4. Now children, we move to the next problem, that is problem number 4, and problem number 4 is also interesting problem. So let's try to solve. Problem number 4 says that water flows in a horizontal pipe. So there is a what pipe? Horizontal pipe means the pipe which is placed on the surface with the same height at both the end. Now water flows into a horizontal pipe whose one end is closed. So one end of the pipe is closed with a valve, and the reading of the pressure gauge attached to the pipe is 3 into 10 power 5 Newton per meter square. Means the pressure in which it is acting on one end of the pipe when the valve is closed is P1, and that pressure is how much? 3 into 10 power 5 Newton meter square per meter square. So this is the pressure when the valve is closed. Okay, when the valve is what? Closed. Now when the valve is closed, okay, that means although the pressure water is inside the pipe only, okay, so in that case the water is basically at rest. So when the water is basically at rest, then the initial velocity of water becomes 0. That means when the valve is initially closed, the velocity of water becomes 0. So that means this B1 0 means the velocity of water is 0. Okay, because when the valve is what? Closed. Okay, now after that, at that time the pressure is 3 into 10 power 5 Newton per meter square. Now the question says that the reading of the pressure gauge falls now to 1 into 10 power 5 Newton per meter square. Now from this pressure, now it will fall to the new pressure, that is P2. That pressure is 1 into 10 power 5 Newton per meter square. But this pressure falls from 3 into 10 power 5 Newton per meter square to 1 into 10 power 5 Newton per meter square when the valve is open. So this is the pressure when valve is open. So you know, when valve is opened, in that case the water will start flowing, okay, due to this pressure, and due to this pressure, sorry, okay, definitely water will flow with a certain speed, and that speed we need to calculate, because in the question says that calculate the speed of water flowing into the pipe. So you have to find the speed of water flowing into the pipe when the valve is open, and that speed I consider as B2. So let me write down B2 with the speed of water flowing when the valve is open. And in this question the density of water is given, means rho is given 10 to the power 3 kg per meter cube. So this 10 to the power 3 kg per meter cube is the density of water. The density of what? Water. So what is the density of water? That is 10 to the power 3 kg per meter cube. Okay. Now in order to calculate this B2, when we have different pressure and the density is given, so we use Bernoulli's theorem. So we use what theorem? Bernoulli's theorem, because Bernoulli's theorem basically applied when an incompressible and non-liquid viscous liquid, when we flow through a pipe, in that case the total energy per unit volume remain constant. But this is for what pipe? This is for horizontal pipe. So children, we are again dealing with what pipe? Horizontal pipe. And children, you know, for horizontal pipe only two energy per unit volume remain constant. One is called pressure energy per unit volume, one is called kinetic energy per unit volume remain constant. So I write down according to what? According to what theorem? Bernoulli's theorem. So according to Bernoulli's theorem, we can write that P1 plus half rho B1 square equals to P2 plus half rho B2 square. Means sum of pressure energy per unit volume and kinetic energy per unit volume remain constant. So that these are the expression that we follow. Now from here, what we need to find out actually? B2. We need to find out B2. So let me just substitute the value. P1 means how much? 3 into 10 to the power 5 plus half rho. Now B1 means already 0. This is 0 with whole square equals to P2 means how much? 1 into 10 to the power 5 plus half rho means 10 to the power 3. Now B2 we have to find out. I write B2 square only. Now this quantity is 0 now. So now I write down 3 into 10 to the power 5. Now this I'll bring the left hand side, minus 1 into 10 to the power 5 equals to 1 by 2 into 10 to the power 3 into B2 square. So let me just subtract. This is 2 into 10 to the power 5 into 2, I write down 2 divided by 10 to the power 3, so that I'll make B2 square as the subject. So children, I have done directly taking this 2 in the left hand side, because 3 minus 2 is 1 is 2, 2 into 10 to the power 5 into 2 multiplied, divide by this 10 to the power 3 will go in the denominator. Okay, now 2 2s are 4 into 10 to the power 5 minus 3 is 2 equals to B2 square. So what actually you need to find out? B2. So I write down therefore B2 means square root of 4 into 10 to the power 2. So just let me take the square root of 4 into 10 to the power 2. 4 square root is 2. Square root of 4 is how much? 2. And 10 to the power 2 square root means 10. So 2 into 10 means 20. So the final answer is 20 meter per second. So children, what is the velocity in which the water flows in that same pipe when the valve is open? Means 20 meter per second. So to calculate by what speed the water flows in any cross section of pipe is calculated even by this Bernoulli's theorem. So we use outer Bernoulli's theorem to calculate the velocity of water that flows in the pipe. And what is the answer? 20 meter per second. Okay, so this is problem number 4. So there are other problems to solve, and that will learn in the next YouTube video.